Hey guys, welcome back to my channel. Bright tutorial. Today we're looking at physical science paper 1 as we're about to write it on Friday. Stay tuned. Don't forget to like, comment and subscribe. Work, energy and power. What is work? Work is the magnitude of the force and the displacement and the angle between the force and the displacement. Okay, work is the magnitude of the force, displacement and the angle between the force and the displacement. Energy is the ability to do work, while power is the rate at which work is done. Let's start with work. We say that work is the magnitude of the force, displacement and the angle between the force and the displacement. By formula, work is equal to F changing x cos theta. F is the magnitude of the force, changing x is the magnitude of the displacement, while theta is the angle between the displacement and the force. Okay, let's say suppose you have a block, a 50 kg block. Yes, it is pulled to the right by a force of 50 Newton. And it has a magnitude of friction force, kinetic friction force of 2 Newton as it moves along a rough horizontal plane A, B. Okay. In order to calculate the work done by each of the forces, or the total work done by all the forces in this object or in this 50 kg block, first of all, you must first draw a free body diagram. Let's draw a free body diagram. This will be the force applied of 50 Newton, and it will have the normal force which always acts perpendicular to the surface. It will also have a friction force, and in this case it is a kinetic friction. Why? Because it is the force that opposes the motion of an object, of a moving object. That's why it is a kinetic friction, because it opposes the motion of a moving object. And we also have the Fg, which is also called weight, and it always acts downward no matter what, but it always acts downward. In order to calculate the total work done by all the forces, that means total work done is equal to the work done by force applied plus the work done by friction force plus the work done by normal force and the work done by Fg, which is also called the weight. Okay, the formula for work is equal to F changing x, which is the displacement, cos theta. Theta is the angle between the force and the displacement. In order to calculate the total work done by all the forces, you have to calculate each work, and then you have to calculate each and every work done by each forces. Okay, let's start by calculating the work done by the force applied. The magnitude of the force applied is 50 Newton, and the displacement will be given at the displacement, maybe it will be 20 meters. 20 meters cos theta. Theta is the angle between the displacement and the magnitude of the force, or in the direction of the force. If you can look at this diagram, the displacement and the force applied act parallel to the displacement. That means it has no angle between, there is no angle between the force applied and the displacement. That means it will be cos 0. Okay, work done by force applied will be equal to, okay, let me take a calculator. it's 50 times 20 cos 0, which gives us 100 or 1000, sorry, 1000 joules, which is a positive work. That means if this force apply does a positive work on the block. Okay, we also calculate the work done by friction force. It will be equal to friction force change in x cos theta, and this theta is the angle between the displacement and the magnitude or the direction of the force. And we are given that friction force is 2 Newton, yet the displacement is 20 meters. Cos theta. Theta is the angle between the displacement and the direction of the force. The direction of the friction force is to the left, yet the direction of the direction of the displacement is to the right. Ne? So the angle between the displacement and the friction force should be the angle between the displacement and the friction force should be 180 degrees. Okay, which will give us let me erase this one. It's 2 times 20 cos 1/8, which give us negative 40 joules. Therefore, the work done by friction force is equal to 40 joules, and it does a negative work. Okay, to calculate the work done by the normal force, let's calculate the work done by the normal force to be equal to the normal force change in x cos theta, which is the angle between the normal force and the displacement, equal to the normal force. With Newton's first law, the normal force is exactly equal to the Fg, or the weight, but in opposite direction. That means normal force is also equal to mg, change in x cos theta, which will give rise to the mass of the object. It's 50 kg times 9.8, which is a constant. Cos theta. Theta is the angle between the displacement and the normal force. The angle between the displacement and the normal force is 90 degrees. Why it is 90? The normal force always acts perpendicular to the surface, so it's 90 degrees, and that will give us 0 joules. Okay, even if you can calculate the work done by Fg, it will also give us 0 joules. Okay, why? That means when we calculate the total work done, we have to calculate. We'll calculate total work done will be the work done by force applied plus the work done by friction force. We will not include the work done by the normal force, and will not include the work done by Fg. Why? Because they act perpendicular to the displacement, or they act perpendicular to the surface, so they does 0 work. So we only calculate the force applied and the friction force, which will be 1000 joules for the force applied plus negative 40 for the friction force, which will give us 1000 minus 40 is 960 joules. I hope you understand this one. Let's make another example. Suppose you have still a 50 kg block. It's moving along a rough horizontal surface AB of 30 meters in this case. Then there is a force applied at an angle of 30 degrees. Force applied. And the friction force, kinetic friction, is 2 newtons. Okay? In order to calculate the total work done by all forces here, the total work done by all forces, okay? First of all, draw a free body diagram. The free body diagram will be the force applied and the normal force, which always acts perpendicular to the surface, and the Fg, which always act downward, then the friction force, which always opposes the motion of an object. Okay, if you can look at this case, the normal force is acts perpendicular to the surface, and the Fg also acts perpendicular to the surface. That means these two forces does no work on the moving object. We will only calculate the work done by force applied and the work done by friction force. Okay, then the work done by force applied will be F, which is will be given, maybe it is 50, using the same values. It will be 50, change in x is 30 cos theta. Theta is the angle between the displacement and the force. The displacement and the force, the angle between the displacement and the force is 30 degrees. Short is 30 degrees. And it will be give us it's 50 times 30 cos 30. It gives us 1299.03 0.04 joules. And you do the same thing or the same approach to calculate the work done by friction force, and you get the answer. Then the work done, total work done, will be equal to the work done by friction force plus the work done by force applied, and you get the final answer. Make sure if you substitute the friction force, substitute it with its negative, because it always does a negative work. I hope we understand this one. Let's go to the type of forces. Types of forces. Okay, we have conservative force and non-conservative force. All right, we have conservative force and non-conservative force. What are conservative force? Conservative force is a force for which the work done in moving an object between 2 points does not depend or is independent to the path taken. And we also have non-consecutive force. What are non-consecutive force? Non-consecutive force are the force for which the work done in moving an object between 2 points depend on the path taken. So it sounds like the same, but it's not the same. Consecutive force is the force for which the work done in moving an object between 2 points does not depend or is independent to the path taken. Yet non-consecutive force will depend to the path taken. So we have conservative force and non-conservative force. I won't write the definition. I hope you understand that one. Okay, examples of conservative force. The most popular example is simply Fg. Fg is a good example of conservative force. Yeah, Fg is a simply good example of conservative force. Okay, there are some other forces, but they are out of our syllabus. There are other forces that you can include on conservative force. But please only stick on Fg as a conservative force. Please only stick on Fg. Do not include the other forces. The electrostatic force is also a conservative force. Elastic force is also a conservative force. But you only have to stick on the Fg. If they ask you about any conservative force, you write the force of gravity. But just in case they ask you about more, then you write the elastic force and the electrostatic force. But we are examined by only the force of gravity. Okay, then the example of the non-consecutive force. Non-consecutive force in all the forces that we are examined with, then except Fg, all the forces except Fg, they are non-consecutive force. For an example, the force applied is a non-consecutive force. The tension is a non-consecutive force. Air resistance, all the forces that you can find or that we are examined with except Fg are non-conservative force. Okay, let me make this clear to you. the difference between non-conservative force and conservative force in order to understand very well the definition, so that you have a vivid picture about what is happening here. Suppose you have a section AB section which have a smooth surface, and you have the section AB which have a rough surface. Okay, let's say there is a block here. This is my block of 2 kg. Okay, block of 2 kg. Remember, let's say I calculate the Fg, or the weight of this block. So if we say Fg, or weight, is equal to mg, it will be 2 times 9.8, which will give us 2 times 9.8, 2 times 9.8 will give us 19.60, okay, newtons. Okay, it gives us 19.60. Let's say this object moves with the gravitational force of 19.60, sorry. When this object moves in the smooth surface, if it moves, okay, if the object moves from point A to point B, what will be the gravitational force at point B? Still, it will be Fg will be equal to mg, and the mass does not change throughout the journey, and 9.8 is constant. It should give us 19.60. Even if it can also move forward through the rough horizontal surface and move to that point here, okay, still the Fg will be equal to mg, and still the mass is 2 and the Fg is 9.8. It will still give us a rise, it will still give us 19.60. Okay, what does that mean? It means even if the object moves from point A to point B, but Fg have remained the same. Even if the object moves from point B to point C, which is a rough surface, but still the Fg remained the same. What does that mean? That means Fg, remember, Fg is a sort of conservative force. I stated that before. Fg is a conservative force. That means all conservative force does not depend on the path taken. Even if I take the path from point A to point B, but still I will have a Fg equal to 19. Even if I don't take the path, I stand here, but I will still have a conservative force of 19.6. I hope you understand it one. Fg, let me state it clear once again. Fg is a conservative force. Remember, it's an example of a conservative force. When the block is standing at point A, it has an Fg, or a weight, of 19.60. Even if the block can move along the smooth surface to point B, still it will have a gravitational force of 19.60. Okay, that means even if it moves from point A to point B, its gravitational force doesn't change. Okay, let's say once again it moves from point B to point C, which is a rough surface. It doesn't matter whether the surface is rough or the surface is smooth, but the Fg will always remain constant. What does that mean? That means as Fg is a conservative force, that means conservative force doesn't depend on the path taken. Whether I move, I'm 19.8, I'm 19.6. Whether I'm standing, I'm still 19.6. It does not depend on the path taken. So I hope you have a clear understanding about conservative force, as Fg is an example of a conservative force, that they does not depend. Even if they are standing, they have the same value, but even if they take a path, still the Fg doesn't change. Let's look at the non-conservative force. Best example of non-conservative force, remember, let me draw another line. Let's say you have point A, point B, and point C. This is a smooth surface, this is a rough surface. Okay, let's say we have a block here, still of 2 kg. This is a smooth surface. That means the kinetic friction force as the object is moving from point A to point B. As the object is moving, it doesn't have a friction force. Okay, I'm sure you will not understand very well if the object is at point A. Let's say we are at point B. Yes, 2 kg block is on point B. Then from point B to point C, there is a rough surface. Then the object is standing. While the object is standing, it has only a static friction force, okay? But while it is standing, there is no kinetic friction. There is no kinetic friction between the object and the surface. So if the object is standing, the friction force is equal to 0 because the object is not moving. But the instant this object move, the instant this object move, it will have a kinetic friction. Okay, let me repeat the statement. As the 2 kg block is standing at point B, it does not have any friction force. You understand? It doesn't have any friction force. In order for it to have a friction force, it has to move a certain distance. In order for the block to have a friction force, it has to move a certain distance. Friction force, remember, it's an example of a non-conservative force. And when the object is standing, it doesn't have friction force. In order to have friction force, the object has to move. That means in order to have a non-conservative force, you have to move. You depend to the path taken. That means all non-conservative force depend on the path taken. Okay. Let's look at energy. Energy is the ability to do work. We have kinetic energy, we have potential energy, and mechanical energy. You only have kinetic energy. There is only kinetic energy in a moving object, and there's only potential energy in a stationary object. That's all I want you to know about potential energy and kinetic energy. I will not go deeper on kinetic energy and potential energy, but all I need you to understand is that kinetic energy is only available to a moving object, yet potential energy is only available to a stationary object. Okay? The mechanical energy is the sum of the two energies. Mechanical energy is equal to the change is equal to the kinetic energy plus potential energy. That means mechanical energy is simply the sum of the two energies, the energy that you gain while you are standing and the energy that you gain while you are moving. It's called the mechanical energy. All right, hope you understand that one. Let's suppose still you have a horizontal surface at point A and this point B, and this is point C. Point A to point B is smooth. Point B to point C is rough. Okay, I want to make a sort of some example. Please stay with me. Don't be bored. I know this lesson might be boring to those who already know. Okay. Let's say we've an object on point A of 2 kg. Yes. And between point A and point B, it is a smooth surface. Between point B to point C, there is a rough surface. Okay, remember that very well. If you move from point A to point B, what will be the potential energy? Remember, potential energy in formula is equal to mgh. M, you are given that m is equal to 2. G, you are given that it's 9.8 as it is constant. But h is 0. That means it will give us 0. That means potential energy is 0. From point A, the potential energy is 0 since the height is 0. And from point B, the potential energy still is 0 because the height is 0. Even on point C, the potential energy will also be 0 as the height is 0. I hope you understand that one. Okay, let's go for the kinetic energy. If the object starts moving at 2 meters per second, okay, let's say at 2 meters per second, and it's moved from point A to point B, what will be the magnitude of the velocity at point B? Still, it will be 2 meters per second. Why? Because it is moving along a smooth horizontal surface. There is no force that opposes the motion. There is no force that opposes the motion, which is the friction force. It is smooth. So that means on point B, it will also have a magnitude of 2 meters per second as the velocity. Okay? If the velocity is the same and the mass is the same, that means the kinetic energy is also the same. You can look at the formula. Kinetic energy is equal to 1 over 2 mv squared. I said the mass is constant and the velocity before and the velocity after is the same. That means the kinetic energy before and the kinetic energy after is also the same. I hope you understand that one. If the kinetic energy before is equal to the kinetic energy after, that means kinetic energy is conserved. So in this case, from point A to point B, kinetic energy is conserved. Okay, I hope I made that very clear. And potential energy will also be conserved. Why? Because kinetic energy initially, potential energy initially and potential energy final is also 0. It is equal. Potential energy initial and potential energy final is all equal to 0. What does this mean? It means both kinetic energy and potential energy from point A to point B are conserved. The word conserved means they remained the same. I hope you understand that one. What does that lead us to? If both kinetic energy and potential energy are conserved or are the same, that means the mechanical energy is also conserved. That means from point A to point B, mechanical energy is conserved. What does that mean? It means that mechanical energy is conserved only if there are no non-consecutive force, or only if there are conservative force acting on the object. You see, on this case, there is no non-consecutive force. There is no opposing motion, which is the friction force. That means mechanical energy is conserved. Or in other words, I can say that mechanical energy is only conserved when the force acting on the object or the force acting on the block is Fg only. Therefore, mechanical energy is conserved. Remember, if mechanical energy is conserved, that means mechanical energy before must be equal to mechanical energy after. Sorry about the handwriting. Remember, mechanical energy is 1 over 2 mv squared. Okay, mechanical energy is 1 over 2 mv squared, which is the kinetic energy, plus mgh, which is the potential energy. This will be initial, equal to 1 over 2 mv squared, final, which is the kinetic energy final, plus mgh. Okay, you can only use this equation. You can only use this equation when mechanical energy is conserved. Mechanical energy is only conserved at point A to point B. Why? Only consecutive force acts on the object. So from point A to point B, mechanical energy is conserved. So you are able to use the formula which says mechanical energy before is equal to mechanical energy after. Why? Reason being, from point A to point B, mechanical energy is conserved. Then you can use this formula. Note, you are not allowed to use this formula if mechanical energy was not allowed, or mechanical energy was not conserved. Sorry. Mechanical energy will be not conserved if there is friction force. Therefore, it is not conserved because the mechanical energy before is not equal to the mechanical energy after. Okay? So you use this formula only from point A to point B, where mechanical energy is conserved. Let's say I now move from point B to point C. I then take a move from point B to point C. Remember, point B to point C is a rough surface. Point B to point C is a rough surface. That means this 2 kg block is now moving along a rough horizontal surface. Okay, that will be 1 over 2 mv squared, or my pen. Sorry about this. It will be 1 over 2 mv squared plus mgh. Okay, all these are initial. Remember, from point A, the potential energy from point A to point B, the potential energy is conserved. Why? It is because it is all equal to 0, as the height is 0. M is constant, G is constant, and H is constant, as it is 0. Therefore, potential energy before is equal to potential energy after. That means even though it is rough, the surface is rough, but potential energy is still conserved. Okay. Let's look at kinetic energy. The object is moving at 2 meters per second. At 2 meters per second at point B, and then it moves along the horizontal surface. It can happen that it can come to stop at point C. Why? Because there is an opposing force. There is an opposing force, which is the friction force. Okay. That means mechanical energy before will now be greater than mechanical energy after. Why? Kinetic energy before is greater than kinetic energy after. Let's say from the velocity is 2, then finally the velocity is 1. That means kinetic energy before will be greater than kinetic energy after. As the potential energy is constant and kinetic energy before is greater than kinetic energy after, that means the mechanical energy before will be greater than the mechanical energy after at point B to point C. That means it will be greater than mechanical energy after, which is 1 over 2 mv squared plus mgh. Okay. This is final. Okay. Then if you can look at this formula, there is no such formula in physics. There is no such formula in physics which has the sign of greater than. How do I come about making a formula for point B to point C? Because I must not use a formula which is greater than. Indeed, this formula is correct because the mechanical energy before is greater than the mechanical energy after. The mechanical energy before is greater than the mechanical energy after. Okay? If you can take a look, the mechanical energy before, okay, is greater than the mechanical energy after. Okay, sorry for the inconvenience. Let's look from point B to point C. We said mechanical energy before is greater than mechanical energy after. Okay, and I say that there is no such formula in physics that has the sign which is greater than. Okay, how do I come about having an equal sign there? Okay, take a look, stay with me. This is equal to 1 over 2 mv squared plus mgh. I hope you see that one. My pen has went out of ink. Sorry for the inconvenience. Okay, remember this must be greater than, but let me leave the sign for a while. After the equal sign, it will be 1 over 2 mv squared final plus 1 over 2 or plus mgh final. Okay, remember, in order for me to put an equal sign here, I have to take away the friction force in order for the mechanical energy to be conserved. You see, mechanical energy from point A to point B was conserved. Why? There was no friction force. Then from point B to point C, in order for mechanical energy to be conserved, I have to remove what? The friction force. I have to say minus friction force. I have to say minus friction force. Okay, sorry. Okay, let's continue. It will be 1 over 2 mv squared plus mgh initial will be equal to 1 over 2 mv squared final plus mgh minus friction force. Then it will be equal. But if I do not subtract that frictional force, then the mechanical energy before will be greater than mechanical energy after. Okay, let us continue on the next page. We say that it was 1 over 2 mv squared plus mgh is equal to 1 over 2 mv squared final plus mgh minus the friction force, so that mechanical energy will be conserved. I have to minus the friction force. I have to subtract the friction force so that it acts like it is moving on a smooth surface, yet it moves on a rough surface. Okay, this will be 1 over 2 mv squared plus mgh will be equal to 1 over 2 mv squared final minus mgh. Remember, this object has moved apart a certain distance. It was B, it was C. Has moved a certain distance, changing x. You see, that means the object, the friction force, which is F, have moved a certain distance at a certain angle of 0 degrees. That means I do not have to only remove the friction force, but I have to remove all the work that was done by the friction force. So I have to remove all the work that was done by what? By the friction force. Okay, let me play with the formula. Let me make friction force the subject of the formula. I take friction force to the other side. It becomes positive. It will be friction, work done by friction force is equal to this one, 1 over 2 mv squared final. Let me take this one to the other side. Minus 1 over 2 mv squared initial plus, plus this one, it's mgh final. I separate this one as it moves across the sign, it's minus mgh. Look at this. This means work done by friction force is equal to, look, it's 1 over 2 mv squared final minus 1 over 2 mv squared initial. That means it is a change in kinetic energy. C plus mgh final minus mgh initial. That means it is a change in potential energy. Therefore, you remember very well that friction force is a non-consecutive force. I explained that before. So that means work done by non-conservative force must be equal to the change in kinetic energy plus the change in potential energy. What I'm trying to do here is that I'm trying to show you that you only use this point when you only use this formula. You can use this formula when you have non-conservative force, but you use the previous formula, mechanical energy before Emec, before is equal to Emec after, only if there are conservative force acting on that object. I hope you understand this one. I'll make some few questions later on so that we clearly understand these two differences. Okay, I hope you understand this question. Let's move forward. We also have something that we called wet net. Wet net is the total work done, remember, the total work done by all forces acting on the object. It says that the total work done by all forces acting on the object is equal, that the key, is equal to the change, that the key, to the change in the object kinetic energy. Sorry, there must be object kinetic energy. By formula, it says that work net is equal to change in EK. They will tell you to calculate maybe the velocity given the work net. To calculate the velocity using the work net, you only use this formula. There are alternatives. You can use the work done by non-conservative force, you get the answer. You can use mechanical energy whereby it is conserved, you get the answer. But there are restrictions whereby you will told that you must only use the work net. I will sort of deeply explain this equation when we are doing questions, but work net is the total work. Total work is just work net will be equal to work done by friction force plus all the forces that are acting on that object. So it is simple to get the work net. Then kinetic energy. So if you have all the work net, then you might be able to get the velocity. Okay, I hope you also understand this section very well. I will explain more details when I'm doing videos, and I'm sure it will be posted by the end of tomorrow. Let's end with power. Power, it's simply the rate at which work is done. Power is simply the rate at which work is done. By formula, power is equal to the rate at which work is done. Power is the rate at which work is done. Remember, power is the time, at which work is F, change in X, cos theta, all over time. Let's say you have a block, 5 kg block, with a force applied of 50 at a distance or displacement of 10 meters. Therefore, in 10 minutes, therefore the power will be F is 50, change in X is 10, cos the theta is the angle between the displacement and the force, therefore it's cos 0, all over 10 minutes. This time is in second. Make sure you convert it to second. Then you will get the power. There are two formulas for power. The other one is power is equal to F average velocity. I'm sure that most of you have become bored by the video, so I'd like us to end at this section. We'll continue when we are making questions. When we are making questions. But this formula, this is the average speed or the average velocity. And this is the force. You'll be given the force that is acting on the object, like the 50 newtons force applied. Then you'll say that the object is moving at a speed or at a constant speed of maybe 2 meters per second. So the answer will be 50 newtons times 2 meters per second. Then you get the final answer. Okay, thanks guys. Let's end it here for today. Please don't forget to like, comment, subscribe, and also press the notification button. I know I might not be perfect because this is my second video posting, so please stay calm or stay tuned, like and subscribe. Thank you very much.